Assalamu alaikum. Hope that everyone is well. Welcome to the fifth online class of Maths, Unit 2, Theory of Quadratic Equations. And for today, the topics are symmetric functions of the roots of a quadratic equation and formation of a quadratic equation. Symmetric functions of the roots of a quadratic equation. Symmetric functions are those functions in which the roots involved are such that the values of the expression involving them remain unaltered when the roots are interchanged. Let's make easy what symmetric function is. Let alpha and beta be the roots of the equation ax squared plus bx plus c equals 0. Then the expression alpha squared plus beta squared will be a function of the roots alpha and beta. Why this expression will be a function of the roots alpha and beta? Because the value of this expression will depend on the values of the roots alpha and beta. As function is a rule which relates or connects the dependent and independent side of the equation. Here, this expression alpha plus square plus beta square is dependent on the independent side of the equation alpha and beta. Means in order to evaluate this expression, we have to take the help of the roots alpha and beta, which will be the roots of the equation x squared plus bx plus c equals 0. So as far as symmetric function is concerned, symmetric function is that type of function in which the value of this expression will remain unaltered or unchanged if the roots are interchanged. Means if you write beta first then alpha, means beta square first then alpha square, then there will be no any effect on the value of this expression at all. The value of this expression will remain unchanged, as beta square plus alpha square will be equal to alpha square plus beta square, like 3 plus 2 is equal to 5 and 2 plus 3 is equal to 5. So same is the case with symmetric functions. Evaluation of a symmetric function of roots of a quadratic equation in terms of its coefficient. What this statement states that we are going to find the values of some symmetric functions, but it will be in terms of its coefficient, means in terms of the coefficients of the quadratic equation. As in the previous lesson, we discussed about the relation between roots and coefficients of quadratic equation, that there exists some relationship between roots and coefficients of quadratic equation. That if we add the quadratic means the roots of the quadratic equation, so as a result we will get the coefficients of means the quadratic equation, as b is the coefficient of x, whereas a is the coefficient of x squared. Same is the case, c is the constant term in quadratic equation and a is the coefficient of x squared. So here is the relationship between the sum between the roots and coefficients of quadratic equation. So here we can evaluate these symmetric functions in terms of its coefficient, means we have to use a concept of sum and product of the roots in order to evaluate the symmetric functions. Here the functions given in the equations 2 and 3 are the symmetric functions of quadratic equation. Why this is a symmetric function? Because if you write alpha plus beta or beta plus alpha or alpha into beta or beta into alpha, so there will be no effect on the result then. Here we have some more symmetric functions. Alpha square plus beta square, alpha cube plus beta cube. If you write beta cube first then alpha cube later, so there will be no any effect on the value of these functions. So here these are known as symmetric functions, and in this exercise we are going to evaluate, or we are going to find the values of these symmetric functions. Let's see that what question number 1 in exercise 2.4 states. If alpha and beta are the roots of the equation, here we are given the equation x square plus bx plus q equals 0, then evaluate alpha square plus beta square. It means that taking the help of the roots of this equation, we can evaluate this symmetric function. So let's write this equation here, as this is the standard form of quadratic equation. So here we can derive the value of its coefficients, like the value of a is 1, the value of b is p, and the value of constant term c is q. So here we can, as it was discussed, that we are going to evaluate these symmetric functions in terms of its coefficients. So we know that the coefficient is connected with roots. So we are going to find the sum of the roots, that the sum of the roots will result in the coefficients. So here sum of the root is equal to minus b upon a. The value of b is p and the value of a is 1. So we have the sum of the root as minus p. A product of the root is equal to alpha into beta and upon c upon a, and it results in q. So product of the root is here q. Now what is the main purpose here, or main objective? We are going to evaluate this symmetric function. So let's write this function here. As we cannot find the value of this directly because we don't have the value of alpha square plus beta square, so we have to think here that how we can convert this expression in this form, like in sum and product form, so that we can put this value here, because we cannot put here the value of alpha plus beta. So here is means this symmetric function, the other form of this is written here. You can see here that alpha plus beta, alpha square plus beta square, then plus 2 alpha beta and minus 2 alpha beta is added here. As you can see here that plus 2 minus 2 alpha beta will result again in 0. It means we have done nothing here, means nothing has been added here. Again, if it will result in alpha square plus beta square, but this step will help us, or this form will help us to fulfill our requirement, or to find the value of this expression. So here you can see that if we combine these three terms, so it will make a formula a square plus b square plus 2 alpha ab, and it can be written in shrink form as alpha plus beta whole square, and 2 alpha beta can be brought down as it is. Okay, so we can this you have to remember that the other form of this expression can be written in this form wherever it will be required. So we will convert this in this form in order to put the values of alpha plus beta or alpha into beta. So here we can write this. So we can now put the values. Alpha, instead of alpha plus beta we can put minus p, and instead of alpha into beta we can put q. So hence we have the value of this expression as p square minus 2q. Let's go with the second part of question number 1. Here we have the same equation, so there is no need to find the sum and product of the roots time and again. It depends on you if you are interested to find, so you can find in each part of the question sum and product of the roots. Otherwise, once it is found, so it can be used for all the other parts. So here we can directly start from here, because as sum and product of the root is already found here. So here we have to think again that how we can convert this expression in the form of alpha into beta, or alpha plus beta means sum of the roots. So here we can see that we have alpha and beta in both terms, so we can take common here. So when one alpha is taken common, so alpha square is left. When beta is taken common, so beta square is left here. So here we can again see that we can put the value of alpha into beta, but we cannot put the value of alpha square plus beta square. So we can write the other form of this like this. So here it is written, putting the values of alpha plus beta and alpha into beta. Instead of alpha into beta we can put what? Q, since this is product of the roots, and instead of alpha plus beta we can put minus p, since it is sum of the roots, and again instead of alpha into beta we can put the product of the roots, and here we have the value of this symmetric function here. Next question is of the same exercise, question number 2. Now here we have a different equation, so again we have to find the sum and product of the roots in order to evaluate this symmetric function. So here the equation is written and the value of the coefficients are derived here. A is equal to 4, b is equal to minus 5, and c is equal to 0. Here is the sum of the roots. Minus minus will result in plus, and this is the product of the roots, and the simplified form is 3 upon 2 here. So now we have to evaluate this symmetric function. Okay, so let me tell you here that we cannot evaluate this symmetric function until and unless this symmetric function is written in the form of sum and product of the roots. So here let's simplify it, that how we can convert this in this form. As we know that here we have the fractions and we can solve it by taking the LCM. Here we have alpha square, so it has been broken up here for the ease for taking LCM here. So here b square is again also written 2 times. Now we know that LCM is the product of common and non-common factors. So let's say that what is common. The terms which are circled with red color are the common terms, like alpha into alpha common and beta into beta are common factors, whereas alpha and this beta is the non-common factors. So here this will be the LCM. As we can see here that alpha and beta can be cancelled and one more alpha is cancelled here, so what is left? Beta is left, so it will be written in numerator. Again, plus sign as it is, 1 you can write as it is. Now you can see here 2 beta, so 2 beta will get cancelled or will get divided, and 1 alpha. So what is left here? We have with us 1 alpha, so 1 alpha will go there. Okay, this is now LCM here, since it is symmetric function, so beta plus alpha if you write, or alpha plus beta if you write, it doesn't matter at all. So here we can put the values. Instead of alpha plus beta we can put 5 upon 4, and instead of alpha into beta we can put 3 upon 2 and 3 upon 2, since there is 2 times the product. So here we can see here 5 upon 4 written as it is, division is changed into multiplication for ease, and hence we have taken the reciprocal, because if division is changed into multiplication, so there will be an effect on this as well, so it will be written 4 upon 9, and as a result we will get 5 upon 9 as the value of this symmetric function. So we can see here that how by using this concept we can evaluate these symmetric functions. Question number 2 is means the same question is, but here different part we have, fourth part. So again sum and product of the root is roots are not found here, as it is already found in this question. So we can directly take a start from the main requirement here. We can see here that we have fractions, so we can take LCM here. So alpha and beta can be the LCM. Here you can take the LCM in this method as well, alpha square written as it is, and here we can have alpha and beta square and beta. I hope that you can take the LCM easily. Alpha square when multiplied with alpha will result in alpha cube, beta square when multiplied with beta will result with beta cube. Now you can see that you cannot put the value of this means directly here, because you don't know the value of alpha cube and beta cube, so it means you have to simplify it. You have to think upon here that how you can convert this in the form of alpha plus beta or alpha into beta form. So you can have a cube formula here, a cube plus beta a cube plus b cube, which can be expanded as a plus b a square minus ab plus b square. So hence we can see alpha one time alpha square, so means if you multiply this it will again result in alpha cube, beta one time in beta cube, so it will result in beta cube. If you multiply these two brackets you will get this as a result. So hence means formula is the shortcut of multiplication here. Okay, here you can see that you can you have here sum of the roots. Now we can have here the product of the root as well, so combine these two terms here. Now you cannot put the value of alpha square plus beta square because you don't know it. So again we have to write this in the form of alpha plus beta square minus 2 alpha beta, as it was discussed earlier as well. Okay, so alpha plus beta we can 5 upon 4 and minus 2 alpha beta, and minus 2 alpha beta minus minus will result in plus. So how many alpha beta you have? You have 3 alpha beta here. Okay, now we have to go ahead. We have to go with the calculation here. 3 3s are 9 upon 2. Again we have to take the LCM 16 and 2, and the LCM is taken, it will result in 16, then 25 here. Now means 16 when divided by 2 it will result in 8, and 8 and 9 will result in 72. I hope that you can you know how to take the LCM here. So 25 minus 72 will result in minus 47 here, and hence we have subtracted multiplied since we have bracket here, so 47 is multiplied with 5 and 16 with 4, 64. By further simplification we can get minus 235 divided by 96 as the value of this expression here. Next question is question number 3. Here you can write as question number 3. Let me write here for you. This is question number 3. If alpha and beta are the roots of the equation, here is the equation written, then you have to evaluate this expression here. Okay, again since the equation is different, so we have to find first the sum of the roots and product of the roots here. B upon a and c upon a, these are the sum and product of the roots. Now we have the expression here, as we know that alpha and beta are common in both of them, so here 2 alpha square can be taken because alpha square is present here as well and here as well. Same is the case beta square here as well and beta square here as well. So we can take maximum terms common here, alpha square into beta square, and inside we have 1 alpha and 1 beta. Since both of them have square upon it, so we can write it as a whole square form. Alpha sum of the root is equal to minus m upon l. So instead of it, the value is written, and instead of alpha into beta, n upon l is written, which is the value of the product of the roots. Here we can see that brackets are here, so we can multiply m with n minus mn square. This square is, and n square into l square, it will l square into l will result in l cube. Okay, here we have the value of this expression. Now this is now equation exercise 2.4 is done. Here we have to go with the next topic. Here this the next topic is formation of a quadratic equation. The topic states that how we can form a quadratic equation, as mostly we are given the equations, and as it was given in chapter 1 that you were given different types of equations, quadratic equations, and you were supposed to solve those quadratic equations. However, in this exercise you will be given the roots, means the answers. This will be opposite to chapter 1. This exercise you will be given the answers, the roots, and you are supposed to find the quadratic equation, means answers are given and you are supposed to find the questions. This is a very, we can say, interesting topic here. Like you can see here that if alpha and beta are the roots of the required quadratic equation, means the quadratic equation is required to be found here. Means we are supposed to find the quadratic equation where the roots are given as alpha into beta. As a quadratic equation is in terms of x, so means that one of the roots will be alpha and the other root will be beta. As you know that we can write this means roots in factor form as well. Like if you bring alpha to this side, it will be minus alpha. If you bring this side to it will be minus beta. So if you multiply these two factors, so as a result you will get the quadratic equation. Like suppose if you find the answers of a quadratic equation is 5 and 3, so if you write it x minus 5 or x minus 3 and you multiply those both factors, so as a result you will get the same quadratic equation. Fine. So here is done the same. So this is the required quadratic equation, which is in the standard form ax square plus bx plus c. As you can see that by multiplying this means the factors, we have got the quadratic equation here, and you can see here is written sum of the roots and here is written product of the roots. It means that using the concept of sum and product of the roots we can form a quadratic equation. So let's go ahead that how by using sum and product of the roots we can form a quadratic equation. Find a quadratic equation means we can find a quadratic equation from given roots when the roots are given, and we can establish this formula for finding the quadratic equation. The formula is x square. See, sum of the roots. This is sum of the roots. Then we have the product of the roots here. So let's write the standard form of quadratic equation. As we are using the concept of sum of the roots, so sum of the root is equal to minus b upon a, whereas product of the root is equal to c upon a. Now here it is written that rewrite this quadratic equation. As you can see here that if we see here under b we have a and under c we have a, so means we need b, means a and a here, and we have to eliminate a from here. So how we can do, if we multiplied each, if we divide each of these term by a, so we can get b upon ac. Divide, so a has been eliminated from here, b upon a and c upon a. Here you can write the dividing each term with a. Why we have done, in order to get this one. So you can see x square is written as it is. Now ba we have received here, or we have means written here b upon a, but we need minus sign. Here it is plus, so you can break up the sign, factorize the sign. Minus minus will be plus, so we have done here, and c upon a. Now we can, x square is written as it is, minus is written as it is, and instead of minus b upon a, what you have written, alpha plus beta, and x is written as it is. Instead of c upon a, what is written, alpha into beta. So we can conclude here that alpha plus beta is sum of the roots and alpha into beta is product of the roots. So hence this formula is, or this rule is established here. S means a shortcut. Sum of the roots can be denoted by x and product of the roots can be denoted by p. So hence we can say here that using this formula or this rule we can find the quadratic equation if the roots are given, if the answers are given. So using this form or this formula we can find the quadratic equation where S stands for sum and P stands for product. Let's go with the exercise, then you can easily understand it. This is very interesting and easy exercise. Exercise 2.5, question number 1. What is the question? That write the quadratic equations. Means we have to form the quadratic equations having the following roots. Roots are given. As you can see, A and G part 1 and 5 are also the roots of the equation, and 1 plus iota and 1 minus iota are also the roots of the equation. However, the equation is not known and we are supposed to find that equation. So as we know that we have already discussed here that the equation can be formed by this formula. So this formula involves sum and product of the roots. Therefore, we are supposed to find sum of the roots, then product of the roots. These are the roots. So sum of the roots 1 plus 5 will result in 6, and product 1 into 5 will result in 5. Thus, the required quadratic equation will be, this is the formula, x square is written as it is. Instead of s sum, so 6 is written, and instead of p, what is written? 5. So this is the required quadratic equation whose roots are 1 and 5. If you want to verify it, if you want to check that really these are the roots of this equation, so you can again solve this equation. Since we have 3 terms here, so we can go with midterm partition, that by multiplication you get 5 and by addition or subtraction you get 6. So minus sign here, minus minus will give you plus here. So you can 5 and x can be the factor, x making pair x is taken common, minus 1 is taken common, so you have 2 brackets. Same here, x will be 5 and x will be equal 1. You can see here that you have both the values 5 and 1 are the roots of this equation. It means if the roots are given, so by using this concept you can form a quadratic equation. G part is also the same. You can find the sum of the roots 1 plus 1 2, product of the roots. Here it can be a plus b, a minus b, since both the bracket are same, just the difference is plus and minus sign, so a square minus b square. As iota means any term written inside the square root with negative sign will result in iota. So if you go with a squaring of it for your purpose, so you can get iota square is equal to minus 1. So instead of iota square you can put the value minus 1 here, so it will result in 2. Now we can substitute these values in this form of quadratic equation. S2 and p is also 2, so hence this is the quadratic equation. If you solve this quadratic equation by any method, or either by factorization or either by means quadratic formula, so as a result you will get these as a roots. Next question is question number 2. If alpha and beta are the roots of the equation, here an equation is given, then we have to form the equations. We have to form the equations or another equation whose roots are, these are the roots. Okay, the roots of this equation is alpha and beta, but we are supposed to form the equation whose roots are 2 alpha plus beta, 2 beta plus 1. But taking the help of this equation, or taking the help of the roots of this equation, we can form the equation whose roots are this. So let's write this equation and we can derive the value of a, b and c here. Okay, as alpha and beta are the roots of the given equation, therefore sum of the root is 3 and product of the root is 6. So here we have found the sum and product of the roots of this equation. Now our main objective is to form the equation whose roots are this one. So roots of the required equation are 2 alpha plus 1 and 2 beta plus 1. So we can means for finding or for formation of this quadratic equation whose roots are, we are supposed to find sum and product of the roots. So therefore again sum of the roots, sum of these roots means 2 alpha plus beta is the one root and plus sign because we are finding the sum, and 2 beta plus 1 is the other root. So 2 alpha plus 2 beta is written, 1 plus 1 will result in 2. Here we have 2 common in both these terms, so 2 is taken common, alpha plus beta is left. Now you can get an idea that if you will not find the sum of the roots priorly, so you'll get stuck here. Means if you directly start from here, means from sum of the roots of this equation, so you will get stuck here that instead of alpha plus beta, what I put. So therefore this is given for help, that using this equation means the sum and roots of this equation, you can find the, you can form or you can find the sum and the roots of this as well. So here you can do it and you can find the sum of the roots. And here we have the product of the roots, means this roots should be multiplied. 2 2s are 4 alpha into beta, 2 alpha, 2 beta, and 1 1 is 1. Again you can see here that if you will not priorly find the alpha means product of the roots, so you will get stuck here that instead of alpha and beta what should I put. So same is the case here, and you have by simplification further you can get 31 as product of the roots. Now you have 8 sum of the roots, these roots, and 31 product of the roots. So when you will put in this equation, so you will get the roots of the means the quadratic equation whose roots are this. Next is again question number 2, but different part, the E part. We have this roots again. Now here we haven't found the sum and product of the roots because already it is found here. So we have directly taken a start from here, means sum of the these roots whose equation is required to be formed. So here we have sum. First of all sum, so here is addition sign here. You can see here that we have fraction here, so we can take LCM here, beta and alpha. As the LCM, alpha plus beta, the value of sum of the root is 3 and the product of the root is 6 here. So here again we can take LCM, 6 is the LCM, 6 3s are 18 and 3 here. By further simplification we will get 7 upon 2 as sum of the roots. Now we have to find the product of the roots. Here this is the first root, this is the second root. Don't multiply it, it will get lengthy, so you just directly write the value. Here we can take the LCM, then we can write the value. Here is no sign, is multiplication, and we will get 3 upon 2 as product of the roots. So here we have the sum and product, so we can put this in the equation x square. Then 7 upon 2 is the sum of the roots and product of the root is 3 upon 2. This is the required equation. However, you can means eliminate the fraction and you can write this without a fraction like this, that by multiplying each term with 2. So 2x square minus 7x plus 3 will be the required equation whose roots are given. Next question is question number 2 again, means, and we have the second okay, we have the first part. The equation is x square plus pxq. The equation is given and we are supposed to evaluate these or we are going to form the equation whose roots are alpha square and beta square. So let's write the given equation whose roots are alpha and beta. We have found the sum of the roots and then product of the roots here. Now we are going to deal with the roots of the required equation. Here the roots of the required equation, again we have to find the sum of the roots in order to form the quadratic equation. So here you can see that we don't have the value of alpha square plus beta square, so we will write in the other form of this as it was discussed earlier as well. Here you can see that instead of alpha plus beta we can put the value minus p. Is you can see here that if we will write this in this form, so easily we can put the values. Now instead of alpha into beta we can put q here, and we have the sum of the roots, product of the roots, since both of them have a square, so it can be written in whole square form, and then we have q square as a result of product of the roots. So the required quadratic equation will be s is the sum of the roots here and p is the product of the roots, q square. So this is the required quadratic equation here. Okay, this we are done here. Exercise 2.5, we're having 2 questions but many parts, so the rest parts you can do. This is very interesting and very easy exercise.